Hey, we are going to do some notes, not that page, over midpoint and distance. I just feel like it works better when we do this on a video, so we're going to do it on a video. So up first, we have a couple of vocab words that are with this section. First is midpoint, which I feel like should be something that's pretty obvious and you could probably guess the definition of without hearing the actual definition. So a midpoint would be something that's halfway, right? A halfway point, specifically in a line. The formal definition that we are going to use is a point that divides or bisects a segment into two congruent segments. Okay, so let's go through there one more time and just kind of unpack some of these words. So a point that divides or bisects. So bisect, bi means two, right? And so this would be dividing it into two parts, into two segments. And congruent means equal, right? Segments just means like a piece. So if I were to, I'm trying to find a color to use. So if I were to have a line that is 4 boxes, right? That midpoint would be here at halfway, bisecting it or dividing it into two equal segments. Segments are just like from point to point, right? This is a segment, this is a segment. Then we have the word segment bisector, which is, let me find it, a point, line, or ray a point, ray, oh, just kidding, there's even more. A point, line, ray, my bad, segment, or plane that intersects a segment at its midpoint. Okay, a point, line, ray, segment, or plane that intersects a segment at its midpoint. Let me see if I can get some examples on here real quick. You have a line, right? It says a point that intersects at its midpoint. So here's the midpoint. Here's an example of a point. If it was a line, you'd have a line jutting out of it looking like that. So there's an example of a segment bisector that's a line. A line's going to go like this through it. A ray would be, here's a point and a line coming out of it. That's a ray. A segment, here's a segment bisector would look like that. Here's an example of a segment. Or a plane. I'm not going to be able to draw this super duper well for you, but here is the coordinate plane, right? Where your x and y axis are. If you had a plane here that was like chopped that in half, I know that's terrible, but that is an example of a plane. We're really not going to have those in this class, but that's fine. Right. We may or may not have talked about midpoint a whole lot back in Unit 2, but I'm going to talk about it a little bit more today, just because it's pretty simple and I feel like kind of common sense, hopefully. Alright, so on example 1, it says find segment lengths. This is supposed to be a picture of a skateboard. There's no wheels on it, don't hate. But it says in the skateboard design, VW bisects XY at point T. And so what all that meant is this line VW and this line XY intersect both at the middle. So like this intersection point of T, it cuts the line VW in half and it cuts the line XY in half. So T is the midpoint for both of those lines there. It also tells us that XT is 39.9 centimeters. So from X to T, this is 39.9. We are supposed to find the entire length of X and Y. So what I'm going to do is I'm going to put XT. XT, it tells me, is 39.9, right? 39.9. And I'm going to add that to TY, which is the other half of this. Now, since T is a midpoint for that line, that means it cuts it directly in half, which, if it's directly in half, means it's 2 equal parts. So whatever the distance of XT is, that's the same distance for TY. That should be 39.9. So I'm just going to add those together. Basically, you could have just multiplied them by 2, right? It's the same thing. And I don't have a calculator on me, but it should be 79.8, and this was centimeters. So again, this is the midpoint. So that means these two lines are equal. Whatever this is as well. We're just adding them together. Example 2, use algebra with segment lengths. Sorry, it's a little crooked. It says point M is the midpoint of line VW. So here's line VW, M is in the middle. Find the length of VM. Again, midpoint means it has chopped it into the middle.
Good afternoon, ladies.
So again, midpoint means it cuts it in half, so it should be 2 equal parts, right? If these two pieces, VM and MW, are equal to each other, then I'm just going to set them equal to each other and make an equation. So now I have a 2-step, multi-step equation, whatever, with variables on both sides. I'm going to subtract 3x from my x's. 4 minus 3 is 1, so 1x. I'm going to add 1 to both sides, and I get x equals 4. Now this isn't my answer because it didn't tell me to find the value of x. It says to find the length of VM. So now I need to take my x value and plug it back in here in my distance for VM. So I'm going to put VM equals 4, plug in my 4 for x, minus 1. 4 times 4 is 16. 16 minus 1 is 15. Doesn't give you any kind of units or anything, so we're just going to put that. Here is a midpoint formula. So in a problem that's not like these, where it's a little bit more basic, this is x plus x divided by 2 and y plus y divided by 2. So we're going to take a moment and go use that formula over here. I'll maybe bring it here so you can see it. All right, example 3. Use the midpoint formula. So here is part A. You have this graph. We have points R, M, and S. It says that the midpoint is M. And I'm just trying to figure out what is the ordered pair for this point, right? I have that these are labeled by 1, but I'm not perfect. We don't want to assume where that point is. We want to prove it with some math. So we're going to take the formula for midpoint. X plus x divided by 2. X plus x divided by 2. Y plus y divided by 2. Okay, I'm going to take the x coordinates of my example. That would be 4 and 1. And I'm going to add those together. Divide by 2. Same thing for the y's. Take your y coordinates. So 2 plus negative 3. Divide by 2. 4 plus 1 is 5, and 5 divided by 2 is 2.5. 2 plus negative 3 is negative 1. Negative 1 divided by 2 is negative 0.5. There is your answer for the coordinates for M. Part B is a little bit harder. It says the midpoint of line JK is point M. So again, you could kind of pretend it looks like this, right? This would be J, this would be K, and there's, again, point M. M is located at 2, 1, and J is located at 1, 4. Find the end point K. So I didn't draw a picture for this one on purpose because I didn't want you to be able to just guess and find it. So what it's saying is you have J, M, and K. We know what J is, it's 2, 1. We know what M is, it's 1, 4. Oh, just kidding. M is 2, 1, J is 1, 4. So 1, 4, 2, 1. We're trying to find the ordered pair for the end point, right? So this one is a little bit trickier. What we're going to do is kind of break apart this formula, right? So for the x's, it's x plus x over 2. And that's your x value for the midpoint. Same thing here, y plus y divided by 2, and that would give you your y value. So I'm going to plug in what I know. I know that the endpoint J has an x value of 1 and has a y value of 4. I'm going to finish in that fraction. What I don't know is I don't know the endpoint K, right? The other x and y value that I would put here. So I'm going to use it as x and y. And I'm going to set that equal to the x and y value for M. Since doing this formula gave us the x and y value for that midpoint, our answer, I'm going to make it my answer here. So the x value for the midpoint is 2. The answer for the y midpoint is 1. Okay, I'm going to solve these equations here in purple. To get rid of that divide by 2, I'm going to multiply both sides by 2. Same thing over here. And that's going to give me 1 plus x equals 4. And 4 plus y equals 2. Solve each side from there. I'm going to subtract 1. I'm going to subtract 4. And I get x equals 4 minus 1 is 3. So here's one answer. And y equals 2 minus 4 is negative 2. Here's the other answer. I'm just going to put those two answers together in the form of an ordered pair. 3, negative 2. So you're kind of working backwards to find one of your end points. And last up here is the distance formula. This is the same thing as Pythagorean theorem. It is used to find the length of a line. It is not used to find slope. It has nothing to do with slope at all, other than, well, I'll show you when we get here on B. So the distance formula is the square root of x2 minus x1, and you square that, plus y2 minus y1, and you square that. I'm going to use this traditional distance formula here for part A, just because it gives you 2 points and only 2 points. So I'm going to label those x1, y1, x2, y2. Then I'm going to plug them into my formula. So D equals the square root of x2, that's 4, minus x1, 2, square it, add it, in parentheses, y2 is negative 1, minus y1 is 3, close it, square it. I would strongly recommend that you do this piece by piece, because we don't really have a lot of experience using these calculators. Some of us, we don't have, I don't know, we just mess up. So I can type this entire thing into my calculator, which me personally I am doing because it's easy. I don't mess up. I take a moment before I hit equals, I check, make sure that I didn't leave anything off, I didn't forget to square it, I didn't forget a plus or a minus or whatever, and I can get my answer, right? If you can't do that because you keep messing it up every time, then what I would do is just simplify your parentheses. So 4 minus 2 is 2, so that's 2 squared, plus Negative 1 minus 3, that's negative 4 squared. Okay, and then from there I got 2 squared, that's 4, and negative 4 squared, that's 16. Just in case you don't believe me, negative 4, it is very important you put parentheses. If you don't put parentheses, it's wrong. Okay, see how I got a different answer. So this is the square root of 20. And you could type the square root of 20 into your calculator at that point and get 4.47. Let's see, it does, I don't know, let's just say we round it to a tenth. 4.5. Doesn't give you any units, so don't worry about units. Alright, and the last one we have is over here at B. So a moment ago I said that the distance formula and the Pythagorean theorem is the same thing. So check this out, right? It is easier to never ever memorize this. Most people, most of you all, probably have Pythagorean theorem memorized. You know it's a squared plus b squared equals c squared, right? So this is not a triangle, but you could make it a triangle. You could have a line here and here. Here's your right triangle, and now all of a sudden you have a hypotenuse, right? I know that we also do this when we're doing slope, and we would count this as a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4 as well. Your slope is not the same thing as distance. If I asked you what the distance of this was, I don't want to see 4 over 4 and it's 1. This is clearly longer than one box, right? This is only helpful if you're wanting to use Pythagorean theorem instead. Now, what I could do is I could find the ordered pairs for these points, right? Like this is negative 1, 2. I could use the ordered pairs like this, negative 1, 2, whatever that is. And I could do this problem the exact same way as I just did over here. Or I could say this was 1, 2, 3, 4. That's my a squared. Plus my b squared was 1, 2, 3, 4. Equals c squared, which is my hypotenuse. It's the ST distance. 4 squared plus 4 squared. 4 squared plus 4 squared, 32. Duh. 32 equals c squared. Take the square root of 32. And you get 5 point, again we'll round and say 7, equals the distance of ST. Okay, so if you wanted to use Pythagorean theorem for distance instead, here is that example.